is manufactured from wood grown in sustainable managed forests and plantations. The timber used for paper production comes either from trees such as beech, and eucalyptus or conifer trees like biscuits, fir and pine. Conifer wood has longer fibers than deciduous species and generally forms stronger papers. When the logs arrive at the wood yard, they breaks into a rotating drum which removes the bark. The logs are then chipped. The largest source of wood chips for paper making is the recycle of cuts from industrial sawmills. Their wood chips are transported to the fluff mill on a conveyor belt. As they enter the fluff mill, the wood chips are fed into digester, where they are cooked in an acid solution to dissolve the lignin and separate the flat fibers, where all the fluff obtained from this process is wood-free because the lignin has been dissolved. The fibers are washed to remove the acid solution and the fluffs now soft and fibrous. Before it can use to make white paper, the fluff is bleached and any residue lignin which causes the paper to yellow with age. To protect the environment, this bleaching is chlorine free. Using oxygen band peroxide, the yellow-brown wood chips that entered the fluff mill have now been turned a soft white fluff. The principal raw ingredient for making paper, this threaded fluff can be dried, baled and transported to another paper mills, which may either not have their own fluff mill or may require a specific type of fluff to give the paper particular characteristics. Whether produced on site or brought on the market, the fluff enters the paper mill and is mixed with water. The fluff solution is refined by passing it through a series of rotating and stationary blades. This gives the fibers a variable degree of clean cut or fibrillated ends. Fibrillated fibers bind more tightly with adjacent fibers, creating stronger paper. Wood fibers alone would produce raw, textured, and unevenly dense paper. And fillers such as calcium carbonate and clay are mixed in to make the paper more opaque and give it more controlled density. Days, optical brightness and sizes may also be blended into the fluff. To improve the appearance of the paper, by far the most important process material is water. About 100 liters of fresh water are needed to make 1 kilogram of paper. Sophisticated wastewater treatment plants and closed water circulation systems on the paper line allow over 90% of this water to be recycled. The fluff solution is now a carefully controlled mix of fibers, fillers, and coloring agents, suspended in water ready to enter the paper machine. The paper machine is the heart of the paper mill, a continuously running series of manufacturing processes that will convert the fluff solution into the perfect paper grade for each market application. The head box is located at the beginning of the paper machine. Here, the fluff solution is injected at high pressure directly into the space between two continuously rotating wires. This carries the fluff into the gap former, which rapidly drains the excess water from both sides. This immobilizes the fluff within milliseconds of leaving the head box, turning into a continuous wave of paper. Still wet and fragile but already exhibiting its most important sheet properties. The delicate paper wave is now carried into the press section by continuously looped wet films, which carry away most of the water and stop the sheet from tearing. At the shoe phrase, the paper web is forced between a soft rotating roller, processing against a hydraulically actuated metal set. Water is squeezed out of the paper by this pressure, and this is absorbed and carried away by the wet films. The longest section of the paper machine contains the drying cylinders. These huge heated rollers dry the paper, giving it the strength to become self-supporting, ready for the process which will determine its surface qualities. The paper sheet passes along the paper-making machine at up to 1400 meters per minute. Every process is continuously monitored to ensure its manufacturing consistency. The paper passes through a machine calendar where to finally follow its steel cylinders. At a precisely determined width effort, ensure that the paper thickness is consistently even. The paper then passes through a series of sizing and cutting process. Here, sketch and coating colors are applied to its surface using a film press process. The coating color is sprayed into an elastic roll which then transfers coating film to the paper web. Film press coating creates a uniformly thin coating layer which follows the surface of the paper. After each coating process, the surface is dried by infrared heating panel and drying cylinders. Seating the surface with sizing encourages printing inks to dry on the surface of the paper, rather than the absorbed into the paper, increasing the color intensity of the finished print and improving the surface strength and the water resistance of the paper. The paper is then wound into a series of steel cores which press against a pop rail. This makes sure that the paper is wound at right tension into each core. Every hour, the paper line clears a jumbo reel containing 80 km of paper sheet, 8.5 meters in weight and weighing 120 tons. The paper machine operators carefully check every aspect of the base paper quality, its thickness, opacity and smoothness, making sure these are exactly as specified, before allowing the robot truck to carry the jumbo reel away for further treatment and finishing process. The final surface qualities of each batch of paper are controlled in the coating and finishing line. For example, the paper from this jumbo reel may be sold with a gloss or matte finish, natural or bright white in color. The coating compounds are mixed according to precise recipes in tank in the coating kitchen. The main color pigment is calcium carbonate, which makes the paper surface white. But the coating solution may also include clay and talcum powder. Binders can be natural sprays or purely synthetic compounds such as latex. To create a smoother surface, up to 2 more coatings per side are applied using the blade coating process. Excess solution is sprayed directly into the paper and is then sprayed curved off by a steel blade. Depending on the pressure of the doctor blade, a uniform paper surface is created, as the irregularities in the paper are smoothed out. Each side is coated and dried sequence to create the correct characteristics for each paper grade. The paper now has the correct base characteristics and the optimum coating consistency. but it does not yet have a perfect surface finish. This is achieved in the super calendar. The paper passes through up to 10 rolls, which is applied pressure and temperature. The rolls have different surfaces such as hard steel and soft rubber, depending on the type of gloss and surface treatment required. As it is rolled back into another steel core for transport, the paper in this jumbo reel now has all the characteristics needed for its use, apart from one final detail, its size. The jumbo reels are transported to a slidder winder. Rotary blades cut the reel into several narrow reels, which are rounded and sent forward to the finishing department. Several reels are simultaneously fed into a sheeter, which cuts the paper into sheets and stacks this into plates. Several printing processes like heat set or offset, cut star and label presses use paper in reel form. These reels remain uncut and are moved forward on automated conveyor belts. Whether the paper has been cut into sheets or a sheet press or remain in a roll for a web offset press, the final destination is the same, the packing lines and warehouse. Each reel of paper is wrapped in craft cardboard to avoid damage in transport. The most important ingredient in a pencil is the graphite, which most people continue to call lead. Contains method of combining graphite with clay is still used, and wax or other chemicals are sometimes added as well. Virtually all graphite used today is a manufactured mixture of natural graphite and chemicals. Two methods are used to form the graphite into its finished state. The first is an extraction method, in which the graphite and wax mixture is forced through a mold to create a spaghetti-like string, which is then cut to precise measurements and dried in ovens. In the second method, the graphite and clay mixture is fed into a machine called a billet press. A flag is placed over the top of the press, and a metal ram extends from the bottom to squash the mixture into a hard, solid cylinder called a billet. The billet is then removed from the top of the machine and placed into an extraction press that processes it through a mold, slicing off strips the size of the pencil core. After being cut to size, the cross pass along a conveyor belt and are collected in a trough to await insertion in the pencil wood, making the wood casings. The cedar usually arrives at the factory already dried, stained and waxed to prevent warping. Longs are then swayed into narrow strips called salts. These are about 7.25 inches long, 25 inches thick and 2.75 inches wide. The salts are placed into a feeder and dropped one by one onto a conveyor belt, which moves them along at a constant rate. The salts are then flattened to give them a flat surface. Next, they pass under a cutter head that makes parallel semicircular grooves, one half as deep as the graphite is thick, along the length of one side of each salt. Continuing along the conveyor belt, half of the salts are coated with a layer of glue, and the cut graphite is laid in the grooves of this salt. The salts without glue and without graphite in the grooves are placed on another belt that carries them to a machine that picks them up and turns them over. So they are laying on the belt with the grooves facing down. The two conveyor belts then meet, and each unglued salt is placed over a salt with glue and graphite, forming a sandwich. After the sandwiches have been removed from the conveyor belt, they are placed into a metal clamp and squeezed by a hydraulic press and left clamped together until the glue is dried. When the pencils are dried, the ends are trimmed to remove excess glue. Shaping the pencils. The next step is shaping. When the sandwiches actually become pencils, the sandwiches are placed on a conveyor belt and moved through two sets of cutters, one above and one below the belt. The cutters above the sandwich cut around the top half, while the lower set cuts around the bottom half and separates the finished pencils. The majority of pencils are hexagonal, so designed to keep the pencils from rolling off surface. A single sandwich yields 6 to 9 hexagonal pencils. Final steps. After the pencils have been cut, their surfaces are smoothed by shaders, and brinz is applied and dried. This is done with burnishing machines, in which the pencils are embraced in a bed of varnish and then passed through a field disc, which remove the excess varnish after drying. The pencils are put through the process again and again until desired color is achieved finally. The pencils receive a finishing coat. The pencils once again are sent on a conveyor belt through shaping machines, which remove any excess varnish that has accumulated on the ends of the pencils. This step also ensures that all of the pencils are the same length. Erasers are then held to the pencil by a round metal case called a ferrule. The ferrule first attached to the pencil either with glue or with a small metal prongs, and then the eraser is inserted and the ferrule clamped around it. In the final step, a heated steel die presses the company logo into each pencil.